So as you can see, this is going to be run in on localhost. Currently not. The servers are not running, so we have one file here for the front end, and we have simultaneously another one we have to run for the back end. I've just split it up into two. So I've just run the front end and the back end scripts. Both are running successfully, as you can see. Now if we reload the page, we can see that the page is compiling in our front end React. Authentication status is false because we aren't signed in with valid user credentials. So this is what we'll show next. So to fulfill the MERN stack, we've used MongoDB as the backend alongside Node.js. So initially I'm going to show you what the UI will look like for a user that has completed the lesson that we have implemented. In this case, Brandon here is one of the existing users in our MongoDB database. Under the table users, password is hashed to follow proper strict database practices. So we're going to go ahead and log in as Brandon. His password is just simply 123, password 123 exclamation mark. Obviously, if we type in a wrong password, a 401 error status code is sent to the front end and triggered. Also, the form is completely validated. So now we're going to sign in with the correct credentials. Oops. One exclamation mark. And that should take the user to their lessons page. Also, they can sign in, log out. So if we refresh the page, we can see authenticated is back to false. So as you can see, I've developed the easy lesson, but this might be subjective depending on the learner, as some learners might actually find it easy as intended, and some learners might find it actually quite challenging. So to help calibrate the difficulty labeling of the lesson, if the user hasn't already done so, then after the lesson completion, they are provided this form that you can see, which basically collects information such as whether the lesson was too easy, just about right, or too hard, how long they spent on it, and they can also provide additional feedback. So in a nutshell, the aim is to address the fact that difficulty labeling is subjective. So the provided feedback will help calibrate the lesson's difficulty in future builds based on direct feedback from the learners. Okay, now let's fill in the review for Brandon. Let's say he thought the lesson was just about right. He spent 32 minutes, and he also gives us additional feedback such as part 1 was easy, but part 3 was hard. So if we go to the lesson reviews table, we're going to refresh. There should be nothing here, yep, because we haven't submitted. Now we're going to submit. Thanks, your feedback helps calibrate difficulty. If we refresh the table, we can see Brandon's review appears here in real time. So now I'm going to show you how the UI might look or differs for a user that has completed level 1 Networks Rookie. So if we go to my dashboard, we can see that the level 1 Networks Rookie badge is visible, otherwise it would be locked and blurred out like the one below. If we go to my stats, we can see Brandon's statistics across the lesson. At the end of the lesson, he accumulated 655 points, and this actually put him at leaderboard rank number 1. So if we go to the main lessons page, we go to check leaderboard, we can see that Brandon is at the top of the leaderboard with 655 points. So now I'm going to demonstrate the password change flow and the JIT coach, or just-in-time coach. So I've already directed myself to the password change page. In settings, I've already entered Brandon's current password, and for the new password we will use banana123. It can be any strong password, and there's also a live strength indicator below to tell us whether the new password is good or bad. So this is the ideal scenario, scenario number 1, where the current password is correct and the new password is at least of strength strong. If both of these conditions are met, which in this scenario it is, the password change is immediate and the just-in-time coach will be ignored. So we're going to go ahead and click update password. The UI gives us a nice loading state. Password was updated successfully. So now we're going to log out and see if the new password works. So we're going to see log in as Brandon. We'll type in the old password, which was password123 exclamation mark. Obviously that doesn't work because the correct new password is banana123 exclamation mark, which then gives us a correct login successful message. So to now show the less favorable option, triggering the JIT coach, which basically operationalizes the lack of microtasks in mainstream platforms, I've already entered Brandon's current password, which is now banana123. We're going to try change his password once again, but this time with an extremely weak password reinforced by the strength indicator down here. Now we're going to click update password, and as you can see, a JIT coach or just-in-time coach appears on the right hand side. So the JIT coach is completely guided. It helps users complete the task through prompts. So obviously banana, not quite, banana123 is easy to guess. It helps the user understand why this is not the correct option. Correct dash horse dash battery. Better, password is better but uses common words. Again, not the right option. And finally the correct one is this. Exactly, that's random, long and unique, reinforcing CISA's recommendations. And as long as this is set and done correctly, a new password that is strong is also set. The update password will work. Just to quickly show though, if the current password is wrong, is returned. So if we go back to the backend logs, again it has triggered a invalid password 401 message. But let's change this back, and we're returning back to being password123, and the JIT coach has been completed. If it hasn't, then it won't allow us. Finish the quick exercise to continue. As long as both sides are addressed, current password is right, new password is strong, and the JIT coach is completed, then the password change will take effect. So now let's try create an account, go through the lesson that we've implemented and claim the badge, and then if possible also appear in the leaderboard. So I'm going to click on don't have an account, which redirects us to the sign up page. For the username, I'm going to set it as Nathan. Password, we're going to keep it simple again, setting it to password123 exclamation mark. And we also have to provide an AI feedback preference. So this will be basically used in part 2 of the lesson, we'll cover this later, to provide the learner with adaptive hints. So if they choose option number 1, detailed hints, then the hints provided in the open-ended section for part 2 will be more detailed compared to someone who chooses that they prefer option number 3, minimal hints. So we're just going to set it as option number 3, I prefer minimal hints. Again, the form is completely validated. So now let's click sign up. Sign up successful, redirects us back to the login page where we can log in as the newly created user. Password123. Doesn't work. Correct credentials only. Login successful. As you can see, we also now have a big bright orange launch lesson button instead of what we had previously on Brandon's page. Just before we launch the lesson and complete it, I want to draw attention to Nathan's dashboard. As you can see, since he hasn't completed the lesson or claimed the badge for that lesson, it's locked, it's blurred out. And same with the statistics, there's nothing in the database, there's no telemetry or information to pull from the database because he hasn't completed the lesson. So obviously this will get populated after the lesson has been completed. All that is shown is leaderboard rank number 3. But do not worry, this is joint leaderboard rank number 3 with Georgian at 0 points. So most likely after the lesson is completed, Nathan will actually be in third place with points. Just to quickly touch on accessibility, I wanted to show the dark and light modes and system. All these options are available, but for the sake of this demonstration, I'm going to keep it in light because I think it looks nicer. So yes, let's click on Launch Lesson, which redirects us to the Lessons 1 overview page. There's a text-to-speech option down here, which further adheres to the accessibility features I've implemented in this prototype.
In this module, you will learn about the different types of networks and explore how two devices in a TCP network reliably communicate with each other. You will also meet the CIA triad, confidentiality.
I'm going to stop it there, but you get the gist. Yeah, now we're going to click on Start. First time compiling takes a while, which redirects us to part 1 of 4. So each page will show the user's progress throughout the lesson. The progress bar automatically updates depending on the lesson part the user is on. Secondly, on the left-hand side, we have the main star of the show, which is the lesson card, which tracks primary lesson statistics such as points, errors, and hints. Other telemetry are also tracked, but they aren't shown to the user. So for part 1 of this lesson, the user is exposed to basic networking knowledge, such as the different types of networks, and they're also shown or introduced to the CIA triad. After the learner has read through the lesson material, they must start the quiz here at the bottom, complete the quiz, collect the flag, and then enter the flag here in this box to complete this part and then proceed to the next. So now let's start the quiz, and this way I will be able to show you how the front end sends the user specific data collected during this task or this lesson part, how it sends it to the back end, and how the back end processes it and updates the MongoDB database, therefore fulfilling the MERN stack. So let's quickly go through these quiz questions, and then I'll be able to show you the lesson card update in real time as we get answers wrong, use hints, and get answers right. The first one is obviously true. Points have been updated successfully. Second one is Bluetooth, but we're going to provide the wrong answer, so errors is incremented to 1. Correct answer should be Bluetooth. The next one, let's use a hint. Just note that the points are 100. After using the hint button disables and the points reduce, and the hints used increments by 1. Should be 3 answers or 3 locations separated by commas. I'm not sure. Let's see. Let's review the content material or lesson material. Oh yes, here's the answer. So it can be any of these options. The answers here. Let's say the user types in the wrong answer. Again, incremented by 1. Errors. And then lastly again, 130 points. We're going to use the hints again. Correct answer is confidentiality. Points have decreased because we just used the hint. Check answer. And then the flag is revealed, which we copy and paste into here. Before I click on check flag, I just want to briefly touch on the process of sending, processing, and returning data in the prototype. So when we click check flag, the front end will send all the collected data from this lesson, such as points, 165 errors, to hints used, to this API endpoint, Express API endpoint that we have developed. Specifically, API save details part 1. You also have the exact same here. API save, then we go to the lesson router, which is here, details part 1, and then we have the controller logic, the logic that basically occurs when data is sent to this endpoint, which is this. It expects username, points, wrong answers, hints, time to complete, lesson status, lesson flag from the request body. It validates that and then does an idempotent upsert, which basically means if the record already exists in the database, then it is simply just updated. Otherwise, a new record is added to the database. This is just to follow proper database practices. And then depending on how that went, how that write to the database went, a 200 status code is returned to the front end and the user is redirected to part 2. So each time a user completes a task or a lesson activity and tries to proceed to the next section after entering the correct flag, a payload is formed using that user's lesson or part data. The specific API endpoint is called, so API save details part 1, part 2, part 3, and the appropriate controller logic is enforced, and then a status code is returned, or a response status is returned to the front end, which basically informs how the UI then proceeds. So now we're going to click check flag. Just before I do though, I want you to see that the table that stores information from part 1 doesn't have anything here for Nathan. There's Brandon's information, there's Anisha's information. So I'm going to click check flag, and we are redirected to the next page, which immediately updates the progress bar, the lesson card context, or user statistics, telemetry, they persist, and the actual course material, lesson material is provided. And then if we go to the table and refresh, we scroll down to the bottom, we can see that Nathan's information has been added for lesson ID 1, part 1. So part 2 introduces learners to basic TCP fundamentals and then engages them in a short open-ended question that's marked by AI, or in this case, ChatGPT. And then the exact same quiz component is provided, and then enter it here to proceed to the next part. So now let's complete the tasks on this page. Let's say Nathan has read through the lesson material, and now he's ready to answer this question. I've prepared 2 answers. We'll go with the bad answer first. We'll paste this here. It's kind of out of context, doesn't really make sense, and it's not specific to the question that we have asked the student, so this should return a bad grade. We're going to click get or grade my answer, and as expected, the AI gives us a score of 3 out of 10, which is a fail, and it's given us a feedback and suggestion. So now let's click on Get Hint. So remember, we set an AI preference on the sign up page. This is where it comes in handy. So if I remember correctly, we prefer minimal hints. So the hint that's going to be generated by ChatGPT will be minimal. There we are. Think about the 3 steps: sin, synac, and ac. What could disrupt the final acknowledgement? And after reading this, let's say the user types this answer. So we've had 1 bad attempt. Let's click grade my answer, or grade my answer, and now we get a good grade, 8 out of 10, and this section is disabled, so we've passed the open-ended question. I'm just going to quickly go through the TCP deep dive quiz. Going to make a bunch of errors, use hints, and then I will get back to you. So we've just completed the quiz. We've been given the flag, so we're just going to copy it before it disappears. Feel free to read through the questions and answers. We're going to enter the flag here. As you can see, the points I got, the amount of errors and hints I've used or made. So now pretty much the same as before. The front end compiles a payload. This time we've got username, hints, wrong answers, time to complete section, as well as the AI scores that we scored on the open-ended feedback. So the 3 out of 10 and the 8 out of 10. The average that we scored, so that should be what? 5.5, 8 plus 3 divided by 2. Very simple. And then the same flag-related stuff. Again, this is sent to the appropriate API endpoint that we've developed, which is this router. this actual specific route, this controller, which, like I've said, expects username points, wrong answers, hints, AI scores, average AI scores, validates them, and then carries out an idempotent upsert safely, and then a status code is returned, which informs the front-end UI how to proceed. So before I click on check flag for part 2, just want to show you the table. There is nothing here. Just going to refresh. Nothing here related to Nathan yet. I'm going to click on check flag, and there we are. We are forwarded to the next part. Like previous, progress bar is updated, lesson card statistics persist, and the task is ready for completion. If we now head back to the table, there's only 2 items here, but if we refresh, now there's 3 items. So if we go down to the bottom, we can see Nathan's part 2 statistics, lesson statistics, average AI score 5.5. We have an array storing all the scores he just got on the open-ended question, which first time was 3, and then on the second attempt was 8. So for part 3, I've actually introduced learners to a TCP three-way handshake simulator, which requires them to correctly enter consistent ports in each of the packets, whatever that be, and then also set proper TCP flags, so SYN, SYNAC, and then ACK. And if they do this correctly and submit the handshake, they can collect the flag and continue to the final part of the lesson. So like before, whenever the user clicks on the submit button here on the left, this API route is what's registered on the front end. It's what's called, specifically the handshake route, and then this is the controller logic. So what gets returned to the front end is mainly these. These are the guided prompts that help the user complete the task. So packet 1 must be SYN, packet 2 must be SYNAC, packet 3 ports wrong, packet 2 ports wrong. Okay, so I've already entered some ports. We're just going to keep it simple, saying 1, 2, 2, 1, and then 122, so it shouldn't be 22, it should be 2, because we have to be consistent with the ports. The second packet should be SYNAC, so let's see what the exercise returns. It's immediately told us that we've made an error. Packet 2 must be SYNAC, so let's change it to SYNAC. Keep in mind the errors have been incrementing each time I've been clicking submit handshake, so that's why we're at 8 now between clips. Yeah, let's see. So we've changed it now, but the port here is wrong. Packet 3 port's wrong. Let's say the user accidentally typed in the wrong port here. And let's just change this here. Packet 2 port's wrong. Oh yes, I realized it's 2. Packet 3 must be ACK. Oh yes, of course. This is the correct sequence. SYN, SYNAC, ACK with proper ports. 1, 2, 2, 1, and then back to 1, 2. So client to server, server to client, and then back from the client to the server. So now we're going to click submit handshake, which reveals the flag, which we paste into here. So we're going to click the check flag. So we're just going to click check flag. Flag correct, moving on. Again, like I've said before, the first compile takes a while, and here we are on part 4, which is the final part of this easy lesson. If we now go into lesson part 3 and refresh the table, we have 4 records. If we scroll down to the bottom, we can see Nathan's information. They took quite a long time to complete this section. It was quite a few minutes, like 10 minutes, I believe. Wrong answers at 11, yep. Hints used at 6. The flags completed, part 3. But yeah, everything is stored correctly. So this final task is to mimic an application style exercise where users apply the knowledge that they've learned. So it's a simple PCAP packet labeling task with an incident triage where they select a basic TCP anomaly and then also provide first mitigations. So now we're going to try complete the lesson as a first time learner. So we have a captured PCAP file here, dummy data, with some extra packet information. If we click on view button, if we click on the actual packet, we can see some information, basic information about it. So here's the first part. Here's the scenario. Multiple users have reported about intermittent outages. A small PCAP file, the one I just showed above, was collected from the Edge firewall, which shows lots of half-opened handshakes. So this is the key to the scenario. Suspicious. So the first step is labeling the TCP packets, which is fairly easy. You just check the left-hand side and then match it on the right. So SYNAC here, we choose SYNAC. SYN here, we choose SYN. Oops. And the same with down here. ACK to match ACK. Then a REST packet to match a REST packet. So I'm going to complete this step and then come back to you. So I've gone ahead and labeled all the packets, TCP packets. Most of them are SYN. That might give you a clue as to the TCP anomaly in step 2. So we're just going to click on SYN, the final one. Actually, 2 of them will label wrong for the sake of demonstration. Step 2 fades in or appears to the user. Here's the overview of the captured PCAP file, 21 SYN packets, 1 SYNAC, 1 ACK, and then 1 reset attempt. So if the user knows their stuff, they can also read the information here, the exercise theory up here. Normal connection uses SYN, SYNAC, ACK. In a SYN flood, the attacker sends many SYN packets but never completes the handshake, which exhausts the server. So obviously the correct answer is SYN flood. At any time the user can use hints. Hints are 7, not 7, 6. After using, let's just use it for the sake. There are 21 SYN packets in the captured file. What type of attack might this mean? Updated. Obviously it can't be REST injection, bad sequence numbers, or none of the above. It must be a SYN flood. Now we have to pick mitigations. Mitigations might include reduce half-open connections, throttling incoming SYN requests, blocking spoofed sources and upstream floods. So SYN cookies, rate limiting ingress filtering, and traffic scrubbing. These are all concepts from the CyBOK document. Scrubbing, rate limiting, and ingress filtering. Let's just pick this as well, as we're a first-hand learner and we might get stuff wrong. So we've got issues here and issues in pick mitigations, or wrong answers in pick mitigations. And once that's completed, we get the final task, which is to draft a small micro playbook. So there are 2 scenarios that could happen. The first scenario is the user enters a bad answer, clicks submit. They actually fail because I don't know if you remember, we labeled 2 of the packets in the labeling task wrong. The anomaly ID identifying the anomaly was fine, but we chose the wrong mitigation, which dropped the grade, and the playbook was completely irrelevant. So in the end, we only got 50 out of 10, which is a fail. So we actually have to click on try again. So instead of actually copying the exact same attempt, I've actually given I've done a model answer. Everything is correct. All the correct mitigations are selected. They've chosen the correct anomaly, and they've also provided micro playbook. So this should be a model answer. In fact, they should probably get full marks. 10 out of 10, 90 out of 10. Okay. Labeling. Yes. Forgot that we actually kept these 2 as SYNAC and SYNAC instead of labeling them as SYN and SYN. The AI completely grades it accurately depending on how each step was completed. And now, because we have actually passed, the finish lesson button appears to the learner. So yeah, here's the stats card, and we are going to finish this lesson. Lesson data successfully saved, and here we are on the badge claim page with some nice confetti animation. The progress bar has completely filled out, saying that we've completed it, and here in green we can claim the badge. So the final few things I would like to show is the actual badge claim. So we're going to click on this, badge claim successful, click on the redirect to, and same as before, we get this review card or form so that future builds of this prototype can take in what learners actually thought about the lesson, namely the difficulty labeling. For now, we're just going to dismiss to keep this demonstration as short as possible. Now Nathan, if we go to his dashboard, his badge should be visible and his stats should be available here as well. On average, he took 713 seconds per section. Makes sense because I was trying to film this demonstration video, used 12 errors, 8 hints, all of which probably helped him get to leaderboard rank number 2, with 620 points, with the highest and lowest grade he got on the open-ended questions, but nonetheless pushed Anisha down. So yeah, that's funny. But yeah, also if you wanted to, you could check in the streak. We reload the page for some reason. Okay, there we are. But yeah, and now the lesson is disabled and marked as completed. So yes, that pretty much wraps up the demonstration for this initial prototype. Just before I go, I would like you to see lesson part 4 table. All of Nathan's information is here, even the answer he gave for the playbook is included here. The amount of points, time to complete, which is the total time he spent, which is awful, but again makes sense because I was trying to film this video. And then if we go to lesson 1 completions, click refresh, we have Nathan here, level 1 networks rookie. He actually got 50 extra bonus points, both set to true, badge claimed and lesson claimed, ID 5. But yeah, I think that pretty much wraps up everything in this demonstration. One more thing I forgot to mention was the security of the prototype. So if an unauthenticated user tries to access any of the routes, they won't be able to. The prototype checks for authentication status in local storage, and then simply redirects the user back to the login page. So settings, change password, leaderboard, all the routes are adequately protected. So although we are using Express's built-in middleware such as CORS, cookie parser, URL encoded, I've also implemented a custom error handling middleware which basically helps me better debug issues as they arise, as you can see here. So yeah, just wanted to quickly touch and mention that. Thank you for watching.